Okay, so you're going to talk about, or we're going to talk about the derivatives of natural logarithms. This is a printout. If you're in the classroom, you can get this. You can either have someone get it or the sub from under the podium. If not, then you can just like write this down briefly and you can get it in class tomorrow. But the derivative of a natural log, so when we take the derivative of ln, what happens is it becomes a fraction. So it's kind of a little bit different than our other derivative rules that we've had thus far. But what happens is we have x, which is in the ln on the bottom, and 1 up top. Now, if it's not just x, we don't always just have ln of x. Sometimes it's ln of 3x, ln of x plus 1, ln of something. If it's ln of u, so if we have a group inside of our ln, what is happening is the group goes on the bottom, and then you just multiply by the derivative. Or the original, what's inside the ln on the bottom, derivative on top. Those are equivalent. This is basically just the chain rule. So let's look at a couple examples here. So our first example, let's take the derivative of the ln of 2x. Well, let's follow this pattern. The derivative of an ln says that we put what is inside of the ln on the bottom. So inside of our ln is 2x. So 2x would be on the bottom. And then the derivative of that goes on the top. The derivative of 2x is 2. Now we can simplify this. There's a 2 on the top and bottom, so we can divide those. We'd have a 1 left on the top and an x on the bottom. Which actually simplifies out to the same thing as ln x, but we go through that process anyways. So if we look at our second example, a little bit more to this one, we're going to take the derivative of the ln of x squared plus 1. Well, same pattern, x squared plus 1 on the bottom, derivative of x squared plus 1 on the top. So the derivative of x squared is 2x. The derivative of plus 1 is just 0, so nothing. So that's our final answer. There's no simplifying that can happen here because on the bottom we have x squared plus 1. So with the x on the top, we can't cancel that because that would be dividing, and dividing does not undo adding. Oh, we don't want to go all the way to number 5. I guess I keep going down. Yep, sorry about that. Example number 3, let's go in order. So let's look at this one. We have the derivative of x times the ln of x. Well, bringing back the oldies, the goodies, this is going to be product rule. So we're going to get to a point now in this class where we are reviewing things that we've done before. Basically, we're just redoing everything we've done before, just with different functions. So this is going to be a lot of remembering stuff from before and combining it with our new rules. So remember, our product rule is first times the derivative of the second plus second times the derivative of the first. In this function, x is the first and ln of x is the second. So when we take this derivative, we write the first, which would be x, times the derivative of the second. That's just ln of x, nothing crazy there, so it's just 1 over x, plus the second, which is ln of x, times the derivative of the first. The derivative of x is just 1. And then we can simplify this. X times 1 over x. Well, multiplying, you can divide those out, and we just have 1. ln of x times 1 is just ln of x. And that's our final answer. Then, let's look at the next one. Example 4. Let's get rid of that. There we go. Okay, cool. So we have the derivative of ln of the square root of x squared plus 4. Well, this would be chain rule, except this is an ln problem. So we can rewrite these. Pretty much the rest of these that we're going to do today, we're going to use our properties to rewrite these. Remember all those properties from last week. The reason why we went all over those is because they're going to make taking the derivative so much easier. So in this case, we are not going to take the derivative in the first step. We're going to rewrite it. So this is going to become, we have not taken the derivative, so we need to leave that notation out front. But remember, a square root can be a 1/2 power, and with logarithms, powers can move to the front. So this is just 1/2 times x squared minus, the ln of x squared minus 4. Don't forget that ln. And now when we take this derivative, it's just the ln times 1/2. So our derivative will just be times 1/2. That just kind of floats down out front. The derivative of an ln, we put what we see on the bottom, x squared minus 4, and the derivative of that on the top. So x squared minus 4, the derivative of that is 2x. Now we can simplify here. We're dividing by 2, multiplying by 2. So when we multiply that out, we just have x over x squared minus 4. And that would be our final answer here. Now moving on to example 5. Okay, a little bit more to this one. But we can rewrite this using our logarithm properties first. So the first thing we can do is this is a 1/2 power, so we can leave that out front, or move that out front. So if we take the derivative, it'll be 1/2 ln of x minus 1 over x plus 1. Sorry, my handwriting on this screen is not fantastic. Then we have another ln property that says if two things are divided inside of an ln, we can write them as subtraction. So I'm going to move this 1/2 out front just so that I'll worry about it later. I don't need to worry about it right now. I can just multiply it in later. So 1/2 times the derivative of the ln of x minus 1 minus the ln of x plus 1. Then we can take our derivative. Well, the 1/2 doesn't change. It's just going to be multiplied out front. ln of x minus 1 on the bottom, derivative of that is 1. Minus, same thing for x plus 1 on the bottom, derivative of that is 1. On an FRQ, you can stop here. But something that you do need to be able to do is combine these two fractions. To subtract these two together, you have to be able to get common denominators. Okay. So, there we go. To get a common denominator, this has x minus 1, this has x plus 1. Well, this one would need x plus 1 on the top and the bottom. This one would need x minus 1 on the top and the bottom. So we have 1/2 times 1 times x plus 1 is x plus 1. Over, leave this multiplied out, x minus 1, x plus 1. You don't need to FOIL that together. Minus 1 times x minus 1 is just x minus 1. X minus 1, x plus 1. Now that these have the same denominators, you can actually subtract them together. Just be careful with subtracting. We're going to subtract the x and the -1, so this basically gets distributed. That's something that can be tricky to keep track of in these problems. So we have 1/2 times x minus x is 0. Those cancel out. 1 minus -1 is 1 plus 1, which is 2, over x plus 1, x minus 1. From here, we're dividing by 2, so those 2's can cancel. We have a 1 left up top, which means there's nothing left to cancel out on the bottom. Sometimes there is, which is why we leave that unmultiplied. But notice this is a difference of squares, x plus 1, x minus 1. So when you multiply these together, it's x squared minus 1. When you FOIL this out, you'll get that. So this would be our finally simplified answer. On the multiple choice, this is probably how you would see this. Let's look at one more example. I know this is bigger, but again, remember we're happy that it's an LN because we can use our properties to separate this. So when we rewrite this, let's see, we have these are being divided and that's multiplied. So we can write this as the ln of x plus the ln, that's a plus, the ln of x squared plus 1 squared, because these are times, can change to adding, minus, because this is division, the ln of 2x cubed minus 1 to the 1/2. So when we take the derivative, this will become f prime of x. Derivative of ln of x is 1 over x. Plus derivative, remember we would move this 2 to the front, so this would just be 2 times. And then the derivative will have x squared plus 1 over 2x. Move this 1/2 to the front, so when we take our derivative, it'll just be minus 1/2. We'll have 2x cubed minus 1 over 6x squared. So to simplify this, really all you need to do is multiply things together, plus 4x over x squared plus 1 minus, we can simplify that. That could be a 3. So this would be 3x squared over 2x cubed minus 1. I know in the last one we combined those fractions, but that was because there was only 2. Make a note, if there are 3 or more fractions, don't add them with your common denominators. Just leave it. Even on multiple choice, you're not going to see them combine those. It's just too much work, really, to get a common denominator with so much. So since this has 1, 2, 3 fractions, just leave it. If you ever just have 2, so this had 2 fractions when we took the derivative, then you're going to get a common denominator to combine them. But if you have 3 or more, you're going to leave it. Okay? And I would like you to practice that. Go ahead and find a common denominator and add them together. If you have more than that, then you can just leave it. That's fine. In Calc Chat, I believe they always combine them. So just look for the uncombined answer when you're checking your work, because I am not requiring you, if you have 3 or more fractions, to find a common denominator with those. Okay, so after this, your assignment is in Canvas.